Live from East Main Street, it's Mr. and Mrs. B!
Okay, yeah, so hello physical science, this is Mr. and Mrs. B gonna do our last video for chapter 3 here. So again, we ended talking about vaporization and evaporation, and maybe how that could maybe be a little bit different than boiling. I kind of alluded to that, and so that is actually what our first point is going to be, is how are evaporation and boiling different from one another. So to start here, it says as you heat a pot of water, both the temperature and the vapor pressure of the water increase. Again, remember vapor pressure increases because, again, more are escaping and they're colliding with one another, and that actually creates a measurable pressure. So at 100 degrees Celsius, some molecules below the surface of the liquid have enough kinetic energy to overcome the attraction of neighboring molecules. So because water vapor is less dense than liquid water, the bubbles quickly rise to the surface, and I'm pretty sure we've probably all seen that before. And when the vapor pressure becomes equal to atmospheric pressure, the water will boil. So,
unless you add salt.
Yes, unless you add salt, then it might keep it from boiling over a little bit. It might be just another little extra thing that you have to heat up, so it might take it a little bit longer to reach that 100 degrees Celsius. And so again, the temperature at which water boils is the boiling point of water, which makes pretty good sense, and boiling takes place throughout a liquid. So as you can see here in the picture, these bubbles again represent, again, what we just said right here is actually when they're overcoming the attraction of the neighboring molecules and rising to the top in the form of bubbles, and again they're turning into vapor at that stage. So again, that is what boiling, again, hopefully we've all seen what boiling water looks like. And then the boiling point of a substance will depend on the atmospheric pressure. So the normal boiling point of water at sea level is 100 degrees Celsius, and at higher elevations, however, the atmospheric pressure is lower, so the boiling point is going to be lower than 100 degrees Celsius. And again, that's just kind of what was mentioned right here, is that when the vapor pressure becomes equal to atmospheric pressure, the water will boil. And so again, when the atmospheric pressure is lower, the boiling point is going to be lower. They're kind of hand in hand right there. And okay, so that is it for, I guess, boiling. And again, remember evaporation. So how that differs from evaporation is that evaporation is just spread out, again, when it's over a large surface area. Boiling point is when it's actually throughout the entire substance. Again, the attractions start to overcome from the bottom first, whereas, again, with the evaporation, it's kind of more at the surface level type area. So that is, again, how boiling and evaporation will differ from one another. And then our next one that kind of goes, again, a little bit of opposite process is condensation. So condensation is the phase change in which a substance changes from a gas or vapor to a liquid. And then condensation is an exothermic process, which means that energy does what?
Exits.
It exits or it leaves. So condensation is responsible for morning dew and the fog that forms on a mirror when you take a shower. So that is, again, the water going from gas to a liquid. So fog, again, if you ever your mirrors, whenever you close the bathroom doors, and again you have to kind of wipe it off with your wipe it off with maybe a rag or something like that nearby. That is actually a liquid that has formed on the mirror.
Or if you put a lid on boiling pot.
Very good. You see the lid on the boiling pot. That is, again, the water vapor hits it and it probably turns back from a gas to a liquid or condenses in the process of condensation. So that is condensation, pretty simple. So now our last two, so you've probably heard of, again, melting, freezing, some form of evaporation and condensation. These next two are a little more unique, and these next two are called sublimation and deposition. And the example that kind of goes really well with this is something called dry ice. So dry ice is a common name for the solid form of carbon dioxide. So maybe if you've seen like a smoke machine or something like that, they usually have dry ice in it, and that is just solid carbon dioxide. And solid carbon dioxide does not form a liquid as its temperature rises. At room temperature, dry ice can directly change from a solid to a colorless gas. And again, that's why it's used quite a bit when we talk about fog machines and creating artificial smoke and things like that. So sublimation, so this is probably a new word for you, so I'd make sure I wrote this down. Sublimation is the phase change in which a substance changes from a solid to a gas or vapor without changing to a liquid first. So usually we don't think that is possible. Again, in most things it kind of goes from solid to a liquid to a gas, from a gas to a liquid to a solid. So sublimation kind of takes the liquid out of the equation. It goes straight from a solid to a gas or vapor without changing to a liquid first, and it is an endothermic change, meaning it does what to the energy?
Sucks it in.
like the jewel thief that you mentioned before. And as dry ice sublimes, again, that's the process of sublimation, the cold carbon dioxide vapor causes water vapor in the air to condense and form clouds, and that is what you see, again, for the smoke machines right there. And another example is this technician is hanging a mosquito trap, and the trap is baited with dry ice because mosquitoes are attracted to carbon dioxide. So that is a real-life application for why we need to learn what we do here. And so to wrap up, our last slide here is going to be the opposite process of sublimation, and it's when a gas or vapor changes directly into a solid without first changing to a liquid, and this phase change is called deposition. So I would make sure I wrote this down. Deposition, again, that's when we go straight from a gas to a solid, and this is an exothermic phase change, which is again the reverse of sublimation, which we just mentioned. And this process causes frost to form on windows. So when the water vapor in the air comes into contact with cold window glass, the water vapor loses enough kinetic energy to change directly from a gas to a solid. So in the wintertime, whenever you have to go outside and scrape off the windows for your parents, and again, you guys might be driving here in about a year or so, you can blame the process of deposition for that, because again, that's what happens. Again, the cold water vapor touches directly to the water vapor touches directly to the cold window, and it causes this to freeze automatically. So Mrs. B, do you have any closing remarks?
Nope.
Okay, so that is it for Chapter 3. Let me know if you have any questions.